Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Raihan Arissaputra. I'm a student of civil engineering at Siliwangi University. In this video, I will explain my analysis about lattice defect.
A lattice defect. A perfect crystal is a crystal whose arrangement of atoms is entirely organized following the arrangement of atoms in certain pattern of crystal. The defect referred to here are defect or imperfection of perfection of the atomic arrangement in the crystal. In fact, the crystal is not necessarily an identical arrangement of atoms arranged in repeated throughout the volume. Crystals typically contain imperfection, which mostly occurs in the crystal lattice. According to the form, lattice defects are divided to point defect, line defect, interfacial defect, and volume defect. The first is point defect. Point defect caused by the vacuum or escape of atom structure. Point defect can be either vacancy which occurs due to not being filled position of atom in a lattice or lattice vacancy site, that is the site that should have been occupied by the atom loses. Vacancy is formed during the freezing process and also due to the vibration atom which result in displacement atom from the normal lattice site. Inertial is misplaced position that should be empty is actually occupied by atom. Inertial diffusion is generally faster than diffusion of inertial void because the bonding with surrounding atom is stronger and there are few positions as compared with the inertial void in the diffusion. Impurity, the presence of parent atom that replaces the place that should be filled by atom. Impurities are parent atoms that are present in a material. Pure metal that consists of only one type of atom is not possible. Impurity can cause point defect in crystal. There are alloys where impurity atoms are intentionally added to obtain certain characteristics of the material, such as the increased mechanical strength or corrosion resistance. Frankel, Schottky and Frankel defect are found in ionic crystal. Schottky defect is in the form of a vacancy at a fine lattice defect together with insert on the surface, whereas if a vacancy is paired with an insert inside the crystal is formed a Frankel defect. Point defect can be seen in figure 2.1. Next, line defect. Line defect cause distortion in the lattice are centered on a line, often called dislocation. In general, there are three types of dislocation. The first, screw dislocation. Screw dislocation from due to the shear force given distortion, as shown in figure 3.1. The second, side dislocation or edge dislocation. Side dislocation is the presence of an extra atom field or half the field, where the side cut off in the crystal. Figure 3.2 shows a schematic of the side dislocation. And the third, mixed dislocation. If the material is found in the two types of dislocation above, it is said that the material has mixed dislocation. Example of mixed dislocation can be seen in the figure 3.3. Next, interfacial defect. In polished crystalline material, solids are composed of small crystals called grains. Its grain can be sized from nanometer to micrometer. At every point, the atoms are arranged in certain direction, and the direction of the regularity of this atom varies from the one item to another item. Boundaries between two pitches of the dimension and generally sparting region of the material having different crystal structure and all direction of the crystal is different. For example, grain boundary, because it is part of the grain boundary of the last bridge and has orientation and direction are not the same atom. The more limit grain, the greater the chance of stopping dislocation. Grain boundary can be seen in the figure 4.1. The next example is twin or special grain boundary. I mean, the one with the other grain granules is a reflection, and this gives rise to defect in the grain boundary regions, so-called grain boundary defect. Twin can be seen in the figure 4.2. And the last, volume defect. Volume defect is the imperfection of crystal in atomic space, namely the appearance of capacities between grain boundaries due to grain orientation and can be seen directly. The presence of volume defect in material usually has an impact. For example, the nature of the material that will cause a change in material density, especially in the presence of pores or a second phase of the material. Volume defect in the material can be crack or porous, inclusion, precipitous, second phase, porosity, and other. Volume defect can be seen in the figure 5.1. Thank you.
That's all from me. I hope you can understand about my explanation. If you have any question or suggestion, please put as a comment. Sorry for all my mistake. Assalamualaikum warahmatullahi wabarakatuh.